In this lesson, we're going to examine one more shape, circles. I saved it for a separate lesson just because it involves separate ideas. It does perimeter, but in a slightly different way. And then we're going to extend our knowledge to area. Hopefully I'll review topics, but just in case, it's a good idea to take a look at the video anyways. So, first thing, circles. There are some special lines that we absolutely positively need to know the name of in a circle. A diameter, which is my line that's in red from A to B. It's joining 2 points and it has to pass through the center, all the way across the circle. A radius, on the other hand, O to A, is joining the center to any point on the outside of the circle. That's our radius. It's halfway across the circle. Using those two values, diameter or radius, you can find the perimeter of a circle, which we actually call circumference. And again, these all should be familiar, but if they're not, welcome to the club. Okay, circumference of a circle is found by pi times diameter, pi d, or 2 pi r, because 2 radius make up 1 diameter. Let's try a couple of those, just get warmed up, find the circumference or the perimeter of each of these circles. So the only real question is, do you recognize what information I'm giving you? This is center out, so that's our radius, so 2 pi r, so 2 pi times 3. Multiply it all together. Use your pi button, please, and you should get 18.85 feet. Yeah, the next one, pi times diameter, because I went all the way across the circle, right through the center, so pi times 12. An exact answer would just be 12 pi, but if we go to decimals, we'll get 37 point, oh, sorry, here, I'll pull my calculator up just so we can all agree. Calculator. And remind you where pi button is. Okay. Pi, so usually it's a shift function. Mine's down here. You see that little yellow there? Pi times 12. Okay, so mine comes up with 12 pi automatically. Decimals, 37.699. So the 2 decimals, that's actually 37.70 meters. The last one, okay, it's half of a circle, but the distance shown goes all the way across it through the center. So this is still a pi d question. It's just we only want half of it. So pi times diameter divided by 2. Okay, into our calculator as we go. I got 6.28. But I do want to point out that that is not the answer, because the question said find the perimeter, which in each of the first 2 questions is literally just the circumference. But in our question we just did now, our circumference is this distance. And the perimeter also includes this distance. Everything on the outside. So you actually have to add the 4 in there to get a perimeter of 10.28 kilometers. Kind of a tricky question there. Circles aren't too tricky. Not really, unless I throw something like that at you. Okay, let's move to other things about circles we should know. Some words you might not be familiar with this time. A chord is a line that travels through a circle, but does not go through the center. That would be a diameter. So my chord is my blue line here. It goes from G to H. Obviously, it misses the center. A tangent is a line that touches the circle on the outside of it and makes a 90-degree angle with the radius. So the purple line here just touches the edge of the circle at point B. We call that the tangent at B. And tangent is a word we use a lot later on in life and math. Okay. And again, it makes a right angle right here with the radius. Somebody might say, well, why do you want to know about these lines? There's stuff we can do with them, of course. So here's some examples. Let's calculate the length of each line segment. I want to find the diameter from A to B, so from the edges through the center. Well, I can do that if I know 2 chords, because these 2 chords make a right angle, and that allows me to apply an idea from yesterday about side C. In this triangle inside the circle, we now can apply a squared plus b squared equals c squared. So a and b, we said yesterday, were interchangeable. So a squared and b squared. C is the one I actually want. Okay, I got numbers on one side, letters on the other, so it's beautiful. I get 625 for c squared. I square root that, and I get 25 centimeters. That's how big that diameter is. If you take a look at the next one, they've given us a radius, so from the center to the edge, and they gave us some chords that go all the way across the edge. And they gave us another radius over here. Here's another radius, and that goes all the way to the edge. And they want us to figure out how big it is from A to B. Well, again, I can do that because I know some parts and pieces. And I have that right angle in there again. So here's my right angle. The side across from it will be side C. The legs A and B allow me to apply my formula again. This time I don't have numbers on one side, letters on the other, so I'm going to move the 3 to the other side. Make sure I subtract it. Into my calculator I go. I get b squared is 16. Square root that and I get 4. I want to point out that 4 is this part right here. But AB is not 4. AB is made up of this section and this section. But the dashes tell me they're both the same, so AB must be 8 centimeters. So the nice thing about circles is you can actually apply Pythagoras to them in many cases, if you're dealing with chords and tangents. And notice we haven't done a tangent one yet, so let's take a look at one of those. Find the length of Q to S. Well, how can we find the length of Q to S in this picture? Good news, we got ourselves a right angle again. So here's a right angle. If this is a straight line, it means this also has to be a right angle, just to point that out. Making this side C, A and B. So I've got A squared plus B squared equals C squared. Into my calculator I go for that. I get 306 for C squared. If I square root, that's going to be a decimal this time. That's okay. 17.49 is C. But the question didn't actually say find O to S, which would be side C. It didn't say to go from here to there. It actually only wanted Q to S. So how could I figure out the distance from here to here, knowing that this entire thing, we just found it was 17.49? Well, the key to recognize there is the radius of a circle, center to any point on the outside, is always the same. It's 9. Well, that means the center to the edge of the circle is 9. So if I take my 17.49 and I get rid of the 9, it leaves me 8.49 centimeters from Q to S. Okay, so some applications of Pythagoras. Good practice from yesterday. Okay, we're going to move into the next topic now. We're going to talk about, actually, I got one word problem for you guys first. Okay, we got a log, a radius, 13 centimeters. So log, radius, 13 centimeters. It's being cut into a rectangular beam. When the first cut is made, there is an exposed surface of 24 centimeters. So what that means is we're going to cut some of this off. We're going to go along with the saw and go, cut that part off. And so let's erase this part here. It's gone, got cut off. And I have exposed surface. We can get rid of these pieces too. We don't need them. We have an exposed surface of, what did it say, 24? Okay, 24 centimeters. What is the distance from the center of the circle, the cross section, to the cut? In other words, what is this? Well, if I go straight up like that, pretty sure it's going to make a right angle. And I can figure out this distance here by thinking to myself, well, that's also 13 centimeters, still a radius. If this is a straight cut, then these are the same. And they're each 12. Well, that allows me to do a squared, b squared, c squared using c, a, and b, okay, where b is 12. So I'm going to do a squared plus b squared equals c squared. Quick rearrangement, 13 squared minus 12 squared. That gives me 25. And if I square root it, I get A is 5 centimeters. So it's kind of like the one we did actually back here. Just to point out to you, it was like this question, except for we had to take the words and interpret the problem to draw the picture. We just cut off this section. Okay, that's our parts of circles. We're going to move to area now. Area is a really important idea. We've talked briefly about area making algebraic expressions for it. Length times width is the area of a rectangle. Base times height divided by 2 is a triangle. Basically, the big idea, area of a shape is how much space it covers. In class, you guys will get a formula sheet. I don't need you to memorize any of the formulas for area, but I definitely need you to know how to use them. That's kind of the key thing. So if you don't have one yet, I'll put one on the website, of course, but you can also come get one from me in class, and I will use it today when we're doing things just to point out which ones we're using. Okay, so we have perimeters too, just to notice this is perimeters all the way down the middle column here. We don't really use perimeters because they're all the same. Add up all the sides, 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 except for the circles, because that one has a formula to it. So the only column I really need to use is the right-hand column in this formula sheet. Area, 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 area. And we'll use these appropriately as we get to them. So let's take a look at our first shape. How many smaller parallelogram tiles with a base of 2 centimeters and a height of 2 centimeters will cover the area of this larger parallelogram? Assume both parallelograms have the same shape. Okay, we can do this. I need to know how many little tiny parallelograms it's going to take to cover that shape up. Well, before I can do that, I got to figure out how big each parallelogram tile covers. So the area of a parallelogram, according to our formula sheet, is right here, base times height. Well, let's apply that. Area equals base times height. In a parallelogram, base and height always meet at a right angle. So 2 times 2 is my base and my height. They told us that right here, right? There's no tricks there. Okay. But for later, make sure your base and your height meet at a right angle. My units are centimeters squared. Okay, let's take a look at the big one. Big one has a picture, so I can find my base and height off of it. And again, they have to meet at a right angle. So here's my base, here's my height. Just want to point out, if you look at this upside down, it kind of makes like a right angle right there, which kind of looks like the letter H, right? H for height. Now, before I do my math, I want to point out something here. Our little parallelogram was measured in centimeters. Our big one is measured in meters. If you have different types of units, you need to convert one into the other. And it's better to do it before you calculate area than doing it after you calculate area. So I'm going to times this by 100, because there's 100 centimeters in 1 meter. Before I start, that gives me 4,000 centimeters. Same thing here, times it by 100. It's 2,500 centimeters to make sure I'm working the same kinds of units. My base is 4,000. My height is 2,500 centimeters. Big number here. Was that 10 million? And that's how much space I need covered by things that are actually only 4 centimeters each. So how many tiles do I need? Well, my number of tiles will be whatever 10 million is divided by 4. I need to break this up into small sections. So if I divide that out, I get 2,500,000 tiles. Okay, that's one of our basic shapes, a parallelogram. All right, another basic shape we can talk about, triangles. So we got Miguel. He needs to sod this area between his fence and the edge of his new pool. About how many square meters of sod does he need? Well, square meters are areas. That's meters squared or square meters. So I need the area of a triangle. Base times height divided by 2 comes right off our formula sheet. That's going to be a triangle. And it's right here. Now, you could also use this one, 1/2 base times height. I prefer the divided by 2 version of it. I just think it makes a little bit more sense. but they both work the same way. Okay, base and height have to meet at a right angle, as in the letter H. Well, here is the letter H, or in other words, there's your right angle. So base is 12.1, height is 5.2. There's no units to worry about converting this time. We're in meters. It talked about meters, so I'm good that way. Oh, don't forget my divide by 2. I got, with my calculator, 31.46 square meters. Okay, that's how much sod he needs. Part B says, if the dimensions are double, does it double the amount of sod needed? Well, let's find out. Let's double our dimensions. So times it by 2, 24.2, times it by 2, and then we get 10.4. What if we did the same question again? So base times height over 2, but this time we used 24.2 and 10.2. Does it actually double how much sod we need? I got 125.84. Well, that's definitely not doubled. That's not times 2. What is it? Well, if we take the 125.84 and divide it by our 31.46, it turns out it's actually 4 times as big. Now, why does that make sense? Well, we times it by 2 here, and we times it by 2 here. So if you take those two things and put them together, 2 times 2 makes, we're timesing our old area by 4. It's kind of why I said back here that you don't want to do your conversion after you do area. You want to do it before you do area, because otherwise you'd probably pick the wrong factor. If you tried to turn meters squared into centimeters squared, you'd probably say to yourself, oh, I have times by 100. But you don't. You got times it by 100, and then times it by 100 again for the other dimension, which means you actually have to times it by, what's that, 10,000? So it's why it's easier to convert before. Okay, we did parallelograms. We did triangles. What other basic shapes do we have? Oh, the fun shape. The wing of an airplane is a trapezoid. Trapezoids are fun shapes. How many square meters of sheet metal are needed for each wing? Well, I noticed a problem right off the bat. It asked us for square meters, and then they gave us feet. So we need a conversion. So here's one of those times where I'll give you a conversion factor. 1 foot is actually equal to 0.3048 meters. So if I need 4 feet for this one, I have to times this by 4. Whatever I do to one side, do to the other. So I'll times that by 4. And I'll get 1.219. And keep a few extra decimals here, 2 meters. It's going to be a little bit exact. If I need 75 feet, well, I'm going to times, I need 75 feet now, so I'm going to times it by 75. So times it by 75. That's a big one. I got 22.86 meters. And same thing with the 30. And I get 9.144 meters. Again, it's easier to make your conversions before you start. Okay, let's go find out how to do the area of a trapezoid. Ooh, it's got a messy formula. So here's my trapezoid formula. I, again, like the top one with the divide by 2 in it, though you could use the 1/2. Totally makes sense. Okay, I'm going to write down the formula so we know how to operate this thing. Area equals A plus B times H over 2. Where A and B, if you actually look at the picture, are the top and the bottom sides that are parallel to one another. And that's kind of important, okay? Parallel, parallel. As opposed to the other sides, these are not parallel, so they can't be the A and the B. So in our diagram, we want the sides that are parallel to one another, which are, in our diagram here, A and B. This side is parallel to this side. They travel in the same directions. That has to be your A and B. So 4 plus 30. H is the height that separates them. It makes a right angle. What technically is happening here with our trapezoid shape is we have 2 bases, a top and a bottom, and the height is meeting both of them. The height in our case is this line down the middle. That's where the right angle is there, and also on that side. Okay. Oh, why did I use 430? We're doing meters, Mr. Casella. Okay. How about 1.2192 and 9.144 and a height of 22.86, all divided by 2? Okay, notice I put it in brackets just like the formula to remind myself, hey, we got to do some BEDMAS here. Okay, so BEDMAS says do the brackets first. Figure out what that number in the bracket is before you do anything else. So we'll get what? 10.353 times 22.86, all divided by 2. And you can put this in your calculator in brackets if you want to and let the calculator do the work, or do it BEDMAS style. And I got 127.43 meters squared. Again, make sure conversions happen first. Trapezoid is usually the trickiest shape because it's got the 2 bases and people get confused which ones the bases are. They have to be the parallel sides, the ones that are traveling the same directions. Okay, last question. Let's see if we can tie this back to things we've done before. The area of the rectangle below is 365. I left rectangles for last because it's one we're most familiar with. We want to know how long the missing side is. Well, how do we find the area of rectangles? Well, I'm hoping we don't need the formula sheet for this one. It's the length times width. This time they've told us the answer. The area below is 365. So I can fill that in for area. My length and my width are these two things. So I'm going to multiply together. Well, based on past experience, it's easiest to put the number in front and the algebra stuff inside a bracket. Now, technically, it's not wrong to write down 3x plus 13 times 5, but it is wrong the way I wrote it, because if I don't remember to put these brackets around 3x plus 13, I'll forget to do all of my multiplying. That's why I prefer this method where I put the number in front. Easier to remember. We can solve by multiplying brackets. That's 15x. 5 times 13 is 65. Same answer you'd get over here, except you'd have to remember to multiply that one and this one, which is the one people forget. Okay, same numbers, just different order. And we've always said order doesn't matter. We're going to solve this. 365 minus 65, numbers on one side, letters on the other. We get 300 is 15x. Divide out the 15s, and x is 20. And if we know that x is 20, we can go back up to this guy and say, hey, 3 x's or 3 20s plus 13 makes 73 centimeters. And we've solved for a missing side using our formula for area. Okay, most of the things here today should be review. We're going to try and start solving more things. That's kind of our big idea, that you know how to do areas already, but we want to solve for missing units or missing sides, or dealing with weird units where we have to make conversions first, or thinking about relationships between things. It's not just our basic old stuff as before. Okay, give the sheet on the website a try. If you're stuck, come see me, send me questions, and we'll go through some stuff together.